Okay, let's have a bit of a talk about tides. Tides play a pretty important role in your boating. About every 6 hours we get a high tide, and about 6 hours later we get a low tide. That's in this part of the world. Now, the bureaus predict tides in tidal prediction tables for us. This particular tide book is a book for Queensland, which covers all the way from the Gold Coast right through to far north Queensland. Now, in the book, it'll tell you all the primary ports. Primary ports start from the Gold Coast, go through to Brisbane, Mooloolaba, right up to the far north Queensland. Now, every primary port will have a list of secondary ports. For example, in the example below, it asks the question about the time of a tide at Victoria Point. Now, Victoria Point is not listed as a primary port. Victoria Point is a secondary port to the port of Brisbane. So below you'll see a list of all the times and the heights for the high and low waters at the port of Brisbane. To find Victoria Point, we would need to go towards the back of the book and find all the secondary ports listed under the port of Brisbane. Okay, so the question below is asking us to calculate the time and the height of high tide on Saturday the 4th of September at Victoria Point. So let's have a closer look at how to do that. Now, in the primary port there of Brisbane, it tells us at 5:20 the height of the tide is 1.51 metres. So the first column is a time column, and the second column is a height column measured in metres. Now we'll talk more about what this height means shortly. Now the primary port of Brisbane is 5:20. What we need to now do is have a look at the secondary port of Victoria Point and adjust that time difference. Okay, so just below the times and the heights of the waters for the Port of Brisbane, you'll see a list of secondary ports, and you'll notice Victoria Point there says the time adjustment in the first column, column 1, is to add 14 minutes to the time of the primary port. So if we were to add 14 minutes to 5:20, the time of the high tide at Victoria Point for that particular morning would be 5:34 a.m. at a height of 1.51 metres. Okay, the example below is given for Victoria Point, but Victoria Point is only one of many places. For example, you might want to visit the town of 1770. You'd need to understand that 1770 is pretty close to Gladstone. So you'd go to the port of Gladstone, look at all its secondary ports, find the secondary place of 1770, and you can do the same thing as what we just did. Get your time for the primary port, do your time adjustment for the secondary port to calculate the times and heights of the waters at 1770. This can apply all over the world, so you need to know where you're going to work out these time and height differences. Okay, so once we've calculated the height of a tide, you might wonder what that depth is actually taken from. Now, tides are measured from a thing called the lowest astronomical tide. The lowest astronomical tide is a benchmark for tidal calculations. Now, that 1.51 metres we just spoke about is a figure above the lowest astronomical tide, or the tidal or chart datum it's also referred to. Another thing you need to understand is that below this line is what is found on the chart. So if we go and have a look at a marine chart or a maritime chart, on the chart we will see numbers which are calculated in metres and tenths of metres. That figure there says big 2 with a small 9. Now the small 9 is a tenth of a metre, so it's 2.9 metres. Now that calculation, or that number, is a measurement taken from the seabed to the lowest astronomical tide. So the depths on charts are measured from the lowest astronomical tide to the seabed. The height of your tide is measured from the lowest astronomical tide to the water surface. If you add those two figures together, you'll get an actual depth of water, which is extremely useful in your vessel. For example, large boats can't go in particular areas at low tide, they will run aground. So if you're the master of a larger vessel, you would need to look at your tide guide and calculate what time of day I can cross certain areas of water. Just to go into a little bit more detail on tides without getting too complicated, tides are caused by the gravitational forces of the sun, the moon and the earth. Have a bit of a look up here. There's the sun. There's the earth. We all know the earth takes 1 year to go around the sun. Then the moon rotates around the earth every 28 days, giving us 4 moon phases. Those 4 moon phases are new moon, first quarter, full moon, and the last quarter. When the moon is at new and full moon, we get what they call is the spring tides. So what that actually means is the high tides are higher and the low tides are lower, causing a larger tidal range. When the moons are at their quarters, the last quarter and the first quarter, we get what they call the neap tides. So the high tides don't rise quite as high and the low tides don't drop quite as far. So the tidal range is smaller for the neap tides. To summarise that, when the moons are full and new, the tidal range is larger. When the moons are first and last quarter, the tidal ranges are smaller. So spring tides for new and full moons, neap tides for first and last quarters. One other thing that's useful to know is that the tide doesn't flow at an even volume. It starts off slow at the top of the tide, and the tidal rate speeds up during the middle of a tide, then slows down towards the end of a tide. Now there's a quick little rule of thumb they call the rule of 12s to simplify this for us. Have a bit of a look up here. There's 6 hours in the tide. 1, 2, 3, 4, 5, 6. In the first hour of tidal flow, 1/12 of the volume will go. Say we're going from a high tide to a low tide. In the second hour of the tide, 2/12 of the volume will go. In the third hour, 3/12. In the fourth hour, 3/12. In the fifth hour, 2/12. In the last hour, 1/12. Now that might seem complicated, but the point we're trying to get across here, and you'll notice that in the middle 2 hours of a tide, we actually lose half of the volume. So the tide starts off slow, starts to speed up, 50% of the tidal volume goes in the middle 2 hours, then it starts to slow down, then the tide will change again. That's what they refer to as the rule of 12ths.